Next we have the octahedral complexes of the type MAA whole thrice. In this it means that we have a didentate ligand. Both of the donor atoms of the didentate ligand are the same, but that didentate ligand is present 3 times. So this is the only possible pair. Obviously there is no other alphabets you can mix and match it with. So this is the only possible pair. So this will be A is trans to A, again A is trans to A. So when they ask you whether it's going to show geometrical isomerism or not, you are going to say no. It is not going to show any kind of geometrical isomerism, but when you are going to write the number of geometrical isomers, you are going to write it as 1 because there is still one possible pair. Now about optical isomerism. So the thing is that this trans pair is getting repeated. So technically it should not be optically active. But again here the catch is if the didentate ligand is present more than twice, that is at least if there are 3 rings present in a complex, then the complex has to be optically active because the complex is going to form a non-superimposable mirror image. This is the reason though because of which because the trans pair is getting repeated, but still the complex is going to be optically active because it is going to form a non-superimposable mirror image. So this is optically active. So if you calculate the number of geometrical isomers, you are going to write 1, and the number of optically active pairs was also 1. So the number of optical isomers is going to be 2. So that's going to make the enantiomeric pair 1, and the number of stereoisomers is equal to the number of optical isomers, which is 2, plus the number of inactive pairs, which was 0. So that's equal to 2. So these were all the octahedral complexes of the type MAA3, where you know AA is a didentate ligand in which both the donor atoms are the same. So next up we have a question on the total isomerism we did till now. So this question is asking you which type of isomerism is shown by CONH3 whole 4 Br2Cl. Okay, so CONH3 whole 4 Br2Cl, if we try to make its coordination number as 6, we can see here 4 plus 6 plus 7 ligands are present. So obviously one of them has to be outside. Now either I can form CONH3 whole 4 Br2Cl, or what I can do, I can take one of the bromines outside and I can put the chlorine inside. NH3 cannot be put outside because the neutral ligand does not satisfy the primary valency. So NH3 cannot be put outside, so either it has to be bromine or it has to be chlorine. So if I take one chlorine and put it inside, and in exchange I put one bromine outside, then you can see these both are ionization isomers. So they are going to show ionization isomerism. So your options can be either A or B. Now let's see what type of complex this is. Okay, so this is the type of a complex MA4, B and C. If we talk about this, this is MA4, B and C. So we have already done this type of complex. We know that for this type of complex the number of geometrical isomers is equal to 2. And we also know that the number of optical isomers for this type of complex was 0. So it's going to be geometrical and ionization. That is your correct answer.